Imagine a standard shipping container indistinguishable from the millions that move goods around the world every day. But with the press of a button, this container transforms, unfolding to release not cargo, but a coordinated swarm of hundreds of drones that fill the sky. This is the reality unveiled by Chinese firm Damoda, and while it's marketed for spectacular light shows, it signals a fundamental shift in modern warfare that is already unfolding on battlefields today. This technology, which blurs the line between civilian entertainment and military application, represents a new era of accessible, scalable, and devastating aerial swarm capabilities. The technical specifications of Damoda's automated drone swarm container system are staggering. The demonstrated system consists of at least 12 flat racks, each loaded with 54 quadcopters for a total of 648 drones in a single container. With one click, telescoping rails extend the racks in a step-down formation, enabling synchronized takeoff without any manual setup. The system is designed for rapid deployment and recovery, with every drone returning to store itself back in the container after the mission, ready for the next performance. Damoda, which holds the Guinness World Record for launching 11,198 drones, simultaneously says the containerized design can deploy thousands of drones, suggesting a scalable architecture where multiple systems can be employed together. Mounted on a standard truck, the container can turn any location into an operational drone stage within minutes, operated by just one person with a laptop and handheld controller. The system includes built-in batteries to recharge the quadcopters between performances, creating a highly mobile, self-contained ecosystem. The military implications of this technology are not theoretical. They are already being realized in contemporary conflicts, though in more rudimentary forms. The system showcased by Damoda is for entertainment, performing pre-scripted routines in a localized fashion, but it perfectly illustrates the threat of weaponized swarms hiding in plain sight. We've already seen a precursor to this in Ukraine's Operation Spiderweb, where Ukrainian forces used covert launchers built to look like small sheds or tiny homes on the back of trucks to attack Russian airbases. That operation, which took months of planning, resulted in the destruction or damage of 41 Russian aircraft, according to Ukrainian claims, with the U.S. Defense Intelligence Agency assessing that Russia lost at least 10 of its prized strategic bombers. A single containerized system could potentially lay waste to every aircraft and vehicle in the open at an airfield, acting as a massive cluster, munition able to evenly saturate an area with effects. Configured for various missions, these swarms could conduct surveillance, electronic warfare, or kinetic attacks, presenting defenders with the nearly impossible challenge of neutralizing hundreds of targets simultaneously. The emergence of these swarm technologies is forcing an equally rapid evolution in countermeasures, creating a technological arms race between drone swarms and anti-drone systems. Defending against hundreds of drones at once presents unique challenges, as traditional air defense systems like missiles and guns are both economically and tactically inefficient against low-cost, numerous targets. Using a $3 million Patriot missile to shoot down a $200 quadcopter is not sustainable. Current research focuses on several key technologies, with directed energy weapons showing particular promise. High-power microwave systems like Epirus's Leonidas, which reportedly destroyed 49 drones in less than a second in a test, can neutralize entire swarms with a single shot. Similarly, high-energy laser weapons offer precision engagement with unlimited ammunition and low operating costs, capable of burning through drones in seconds. However, both systems have limitations. Microwave weapons can cause collateral damage to civilian electronics in urban areas, while lasers are less effective against truly massive swarms as they can only engage one target at a time. Electronic warfare, such as jamming drone communications, remains viable, but is increasingly challenged by autonomous drones that don't rely on remote control and can operate using AI in GPS-denied environments. This technological shift represents more than just a new weapon. It represents a fundamental change in the balance of power and defense strategy. Nations are recognizing this threat. China itself recently displayed its own iron triangle of anti-drone systems, including missile and artillery systems, high-energy lasers, and high-power microwave weapons in a military parade, acknowledging the importance of anti-drone warfare on the modern battlefield. The United States faces particular challenges, as defense experts acknowledge that America cannot compete with China in a one-for-one drone production race, since China is the undisputed leader in commercial drone production, with company DJI holding a 90% share of the U.S. commercial market. This reality demands a different solution, effectors that can be effective against significant numbers of drones simultaneously, rather than the one-versus-one approach that has dominated air defense since its inception. The ultimate implication is that the future of conflict will be shaped not necessarily by who has the most advanced traditional military, but by who can best integrate and defend against the coming waves of autonomous systems that are rapidly moving from light shows to the battlefield. The containerized drone swarm represents a paradigm shift in warfare as significant as the introduction of gunpowder or the aircraft. It makes massed aerial capability transportable, concealable, and accessible, potentially placing devastating strike capacity in the hands of more actors than ever before. The technology demonstrated for entertainment today often becomes the weapon of tomorrow, and the race between the swarm and its defenses will likely define the next generation of conflict. What are your thoughts on these developments? How should nations balance the civilian benefits of this technology with its military dangers? Share your perspective in the comments below.